Our second lecture video on fluids will finish our discussion on hydrostatic pressure and the force exerted by liquids. The total force exerted on a horizontal surface depends on the area of the surface, the depth of the liquid, and the weight density of the liquid. This is a little different than when we were talking strictly about hydrostatic pressure before, because hydrostatic pressure doesn't depend on the surface area. It only depends on the height or depth of the liquid and the weight density of the liquid. The equation for finding the total force exerted by a liquid is that F sub T, or total force, equals A, the area of the bottom or horizontal surface, times H, the height or depth of the fluid, times D sub W, the weight density of the fluid. If we look closely at this equation, it is basically our equation for pressure multiplied by the area of the bottom or horizontal surface. If we are looking at the total force exerted on a vertical surface or the side of a tank, the total force F sub S is found by using the average of the vertical height. Basically, we take the equation to find the total force exerted by the liquid and we multiply that by 1/2. Let's take a look at one example calculating the total force exerted by a liquid. Find the total force on the bottom of the same water-filled tank in our previous example, that is 15.0 feet by 25.0 feet by 8.00 feet high. Let's first write down what we know. We know the height is 8.00 feet. We also know the weight density of water from before, which is 62.4 pounds per cubic foot. We were given the length and the width, so we can find the area by multiplying these two dimensions. The area is 15.0 feet times 25.0 feet, which is 375 square feet. We are trying to find F sub T, the total force exerted on the bottom of this tank. The basic equation to solve this is that F sub T is equal to area times height times weight density. This will also be our working equation because we don't have to rearrange anything. Next, we will substitute to see that F sub T is equal to 375 square feet times 8.00 feet times 62.4 pounds per cubic foot. This gives us a total force of 187,000 pounds. This concludes our discussion on a total force and hydrostatic pressure.